I'll kind of kick us off just in the interest of time while everyone keeps, saying hello. So welcome everyone, and thank you for joining us for another AE member webinar to discuss opportunities to use predictive analytics to improve reliability and resiliency. My name is Ian Watsky, and I'm the Senior Membership Specialist at AE. And I'm joined today by Jeremy Frint and Kenji Yanagisawa. So starting off with Jeremy Frint, thank you, Kenji. Starting off with Jeremy Frint, who is a Utility Engineering Department Manager at EKN Engineering, where he focuses on asset health management, engineering analytics, and process improvement. With over a decade of experience spanning from natural gas pipelines to high voltage electric transmission, Jeremy has led major infrastructure projects across the Midwest. Joining Jeremy is Kenji, who is a data analytics manager at EKN Engineering, where he applies advanced analytics to drive data information decision making and improve project outcomes. As an accomplished analytics expert with a strong background in marketing analytics, data management, and strategic planning, Kenji helps ensure that initiatives are grounded in actionable insight. So before I dive in, just want to say a big thank you to Kenji, Jeremy, and the EKN team for joining us. And before I actually dive in, I'll go over some quick housekeeping for the webinar. So we do have the full hour for this webinar, which is being recorded. And I will be sending out a follow-up email tomorrow morning with a link to the recording. This webinar also offers 0.2 AE credits for live attendance. So that follow-up email that I send out tomorrow will also act as your certificate of attendance to confirm your credits so long as you did attend live. And then I will also include a link to view and download the slide deck from in that same email. We'll have opportunity for Q&A towards the end of the webinar, towards the end of the presentation. So if you do have any questions along the way, please just throw them directly into the Q&A box, and then we'll try to leave the chat open for more general discussion. And that is it for housekeeping. So with that, I'd like to officially welcome and turn it over to our first speaker, Jeremy Frint.
Thank you, Ian. Yes. So as we kind of get started real quick here, we do have 3 questions, a quick little poll, just to kind of help Kenji and myself get acquainted with everyone out there, with the audience. So if you could take just 30, 45 seconds and answer them, just kind of related to where you're at with predictive analytics within your company or wherever you might be, whatever you're with, or where you want to go, kind of the challenges you're facing, what you're seeing, and what might be the most valuable outcome for you for where you're at, and things like that. So yeah, we'll just take a moment, and then yeah, hopefully we can help as we go through the presentation and stuff, address some of those, or hopefully you can see where we can help you with your situation. So looks like, yeah, there's a good portion coming in. And yeah, I do have a few screens up, so just trying to keep everything managed and running smoothly. So if I'm looking away, that is the setup there. But looks like, yeah, the majority are just kind of beginning to explore the analytics portion, things like that. A few that are mature, so that is good to see. Hopefully this will just be maybe a new perspective for those. And those that are just kind of beginning and looking for it, hopefully, yeah, this can get you introduced to some of the ideas that we did and everything like that. So I like to see the better workforce efficiency and prioritization. That was one of our biggest keys that we focused on. So with that, I think we are probably good there. So with that, we'll get into our presentation. Thank you. Yeah, thank you everyone for participating in that. Really do appreciate that there. So today, starting off, I'd like to ask a question. Do you know what assets are at risk within your system and can you keep up, right? So in the United States, there's an estimated 180 million utility poles. And as an example, let's say I have around 180,000 poles in my system, and at any given time, approximately 1% of those poles would be at risk. Whether that's just needing repairs, replacements, what it might be, right? So that gives me, almost 2,000 poles that are at risk within my system at any given time. Now, say if I wanted to go and inspect those to see if, what poles are actually at risk, let's just take, an average 2 hours for that inspection, give or take, right? Just a little bit. That gives me 450 working days or almost 2 years of working days, right? Taking the average of 262 working days in an actual calendar year, right? That's 8 hours a day, 5 days a week, right? So that's quite a bit of time just to inspect that 1%. Now, if I actually had to work on those, right, 4 hours of actual working, whether that's the design side or out in the field, construction, installing, all of that, right? That's 900 working days or almost 3.5 years of work. And that's really just based around that 1% that is going to be at risk or estimated to be at risk within a system. So now that seems like a lot, right? Even on top of that, though, there is also the unexpected, the break-in work, the emergency work that happens from storms or weather events or other things going on that then extends that even farther, right? Even more. And I'm sure there's even other things, right? Of where everything's located, right? You have a really large system and you got to add 2 hours of mobilization to get to those poles, where your laydown yards or your inventory stored, right? There's still even then a lot more factors that will add on to that 900 working days, right? Those hours that just keep going. So it's not unrealistically to say 5 years worth of work, just to prioritize and look at and find that 1%. So how do you prioritize it all? How do you know which assets are at risk? And so that's what we went into. So again, hello and welcome. My name is Jeremy. Introduced a little bit more about myself. Yeah, 7.5 years of designing and building transmission lines, all of that stuff. And then 4.5 years more here on the data-driven data engineering side of things, working to include all of that into the design and engineering world of the utility industry. So I am located and based out of Idaho in the United States. And so, yeah, that's where I am. As Ian said, I am joined by Kenji.
Hi, everyone. My name is Kenji Yanagisawa. I'm head of data analytics at EKN Engineering. I'm based actually out in California, but I'm actually from the Hudson Valley, so I'm glad to see some Newburgh representation. So I wanted to call that out because that's rare that happens. So go Newburgh. I graduated with my BS in electrical engineering, and I have an MBA in corporate strategy. And for the last 20 years, I've been helping organizations throughout the US really leverage their data and their analytics to the fullest, maybe in their marketing organizations, maybe in their strategy and operations. So I've been playing around in a lot of different fields, and now I'm in this field and I'm helping Jeremy kind of figure out the next problem and find the next solution there. So I'm happy to be here, and I'm happy to share some of the learnings with a broad audience.
Thank you, Kenji. Yeah, well, we are excited to share this. Kenji and I have worked very closely together on building this. And today, yeah, we're going to share a bit of our journey into and using the predictive analytics really to try and extract actionable intelligence from that vast amount of data that is generated and processed from today's many sources and technologies. So we are going to dive a bit deeper into our kind of specific use case, which is with and around overhead transmission line structures. And so we'll cover, a few topics: finding, processing the data, how we use the data, and what came of it all, right? And so to start off, as we were going and defining the problem, a sense, what are we looking to solve? How do we need to understand what solution we needed? We asked some what if questions, right? What if we could better prioritize and bundle our work? How could we really know where we needed to spend our time and money and resources? We asked, what if we could update and change parameters depending on events or situations, emergency work, atmospheric rivers, flooding events, things like that? How can we kind of change or manipulate to get, a proactive approach to it? Things like that, changing and running through things. What if we could combine of all of the risk factors, right? Combining the tower's history, repeated work, right? Hey, every year we're going out to the same tower to replace the same foundations or repair the same foundation, right? Factoring that in of, hey, something else might be going on here, right? All of its existing conditions, where it's located, all of that stuff, and known. One of the big things that we did was applying known failures of other structures. Hey, we had a failure on this structure type with this foundation and this soil. So where else do we have that combination, right? And so, that was another question. What if we looked at? What if there was something that could utilize and do all of this stuff? So, and the last one, what if we could have a check engine light per se? What if we could have a tool or a system that could help us know what towers might need prioritized over others? 100-year tower versus a 40-year tower, right? If you just go off of age, yeah, the one, but if it's healthy, what about the other one? What are all those other factors, right? So those are kind of how we helped define and then what questions we looked to answer. And so I am going to turn it over to Kenji to really share and dive in to how we built the tool and our journey answering these questions and what we looked at. So Kenji, take it from there.
Thank you, Jeremy. So as you guys saw, with your peers, you guys are in the journey of just learning about the predictive analytics, and a majority of you guys are really starting that journey. So just like us, we wanted to share some of those learnings along the way and really hopefully help you kind of really learn and develop. So with that in mind, the first thing that we wanted to focus on was the intent. So what I mean by intent is really, what is the purpose? What is that guiding light? Now, what we're really talking about in predictive analytics is, what are we trying to predict? What are we trying to forecast, estimate, analyze? What is that question you're trying to answer? And the reason why I say focus on intent and not the question is because as you develop your predictive analytics and as you develop those models and all the data that you'll have to go through, things will change. You are going to hit bumps. You're going to hit hurdles. You're going to have to get through those hurdles. And the good thing about the intent is that as things change, your intent will stay. Your general questions, the general things that you're trying to do will do. So it allows you to course correct within a scope of work in a way. And goals will change too, because you're going to have business requirements coming in. You're going to have urgent break-in work that's going to come in and throw all your plans, into the window, out the window. So in that situation, goals will change, deliverables will change, but the intent will stay. So that's the other reason why we say focus on intent. Secondly, what we wanted to do is to understand the impact. And from our perspective, we broke it up into two separate categories: internal versus external. That's straightforward. What kind of data points, how we have the impact internally? Is it impact our internal data points? Is it us or not us? That's really what we're trying to answer with internal versus external. Then the second categorization we did was direct and indirect. Pretty straightforward too. We picked these straightforward because it's easy to remember and easy to really help break down the data. So the indirect category is how do we impact the data? Does the data have a direct impact to us? And indirect is synonymous, well, the opposite of direct, right? Is do we have an indirect impact? Is it two ripples out? Do we have a cascading result that we have to think about? So I'll give you a couple examples so to better understand what we talked about. So the first example category we'll talk about is direct versus internal. Now, these are things that you're going to talk about with your assets. Like, you know the information about your own assets, those utility poles. You know where they are. You know when you last saw them, what kind of materials they are, what they're made out of, where they're located, and who's working them, right? And as a result of that, you also know who's done work on them. What kind of maintenance records are there? Those are all internal data points that you have access to, and you can easily manipulate because you can send your team out there, or you can grab those data points like those data and meters from a lot of those flow meters and meters that you'll see out in the network. So those are the examples of direct and internal data points that we want to understand the impact to. The second category was understanding the impact from external and direct data points. So those are things like the community details. For example, when you do something, how does that impact the community? What types of communities are impacted? Are we focusing on urban density? Do we have utilities in place there? Do we have to really think about what kind of ripples will cause, right? Because we want to make sure that we're taking care of everybody and really focusing on making sure that things are there because the network is there to maintain the community, right? So that's why we have to keep that there. Additionally, we wanted to focus on how the resource and inventory is used. We want to be sustainable. We want to make sure that we're not overusing resources. We reuse as much as possible. So we have some really cool things that we've done with that. And we also want to lastly focus on the carbon footprint. What kind of footprint are we leaving in general, but more specifically carbon because it allows us to focus on that. And we will look at any kind of footprint we will do, we will have an impact on. So those are the types of direct, internal, and external. The next example is indirect. Indirect, internal are things like customer details, who our customers are, what they want to do, what services they need, how much they're using. Those are things that we can't control, but have a direct or an indirect impact onto our decisions. Additionally, system data. Now you think, why is that indirect? And I call that indirect is because what you do with one system may have an impact on another system, another node, another network, right? So we have to think about branching and we have to think about those ripples that I mentioned. And then the last category for us was the regulations and compliance, either internal, external, federal, local. Those are things that other people have to impose on us to make sure that the community is safe, right? And then the last category is internal, external. These are things that we really have no control over whatsoever, but we have to live with. Those are typically the geospatial data, weather and forecast. So we'll actually look at upcoming weather forecasts. We'll help prepare for certain situations. We live out in sunny California and, sunny California isn't sunny all the time. So we have to kind of prepare for those situations when those are coming. Those are those environmental elements that we try to think about. So those are the different impacts that we wanted to focus on. And once we defined those impacts, what we went in there with us in our group was this unbiased exploration. And this is a lesson learned that I wanted to share with you guys is that we kind of went in and we were surprised with some of the results. Some of the things were intuitive, but some of the things were deeper learnings. For example, right, slope and elevation. Oh, sorry, rainfall and drainage. We know there's a relationship there. We know that, your drainage and your drainage solutions need to be able to account for the rainfall and estimated rainfall. But what type of relationship is that? Is that linear? Is that exponential? Do we have sudden spikes? Do we have low spikes, right? Deserts, for example, deserts and those dry, arid areas have to deal with low rainfall for a very long period of time, but they're going to have a spike. Can our system do that? What kind of impact does that have on our data points and our results? So the second example we're also talking about is slope and elevation. Now this was a fun one because everyone knows the slope matters when you're building, matters when you're doing maintenance, right? The steeper the slope, the harder it is typically to do. What we found though was when you think about slope alone, straightforward. But when you start to layer in elevation and things like that, at one point, slope doesn't matter. Because at one point, the elevation is actually a bigger hurdle to overcome and deal with. Now you're dealing with how do I get there? Can the material absorb all those things? Can the material stand that elevation that you have to deal with, right? So at one point, you have to kind of shift your mentality. And that's when we're talking about that unbiased exploration. So that's a lesson learned that we wanted to share with you guys is go in there with an open mind. Let the data lead. Let the data talk to you. It has a lot to say. We just got to be willing to listen, right? And the last example that we were kind of playing around with was how does the combination of data work? How does one interact with another, layer in another, right? That's the real world. That's kind of that mentality of there's no simple solution. So some of the things that we thought was fun was how does the soil type, tower height, and flood region impact erosion, right? If the soil is loose, does it actually add risk? Does it help? How does that help? You know, there's ways of architecting the floor and doing the foundation and things like that to account for that. But you need to know what kind of environment you're dealing with. So that's kind of the questions that we were looking to answer and better understand. So that's what we talk about, that unbiased exploration. It's just go in, yeah, have a couple of notations, do have a hypothesis, have an intent, understand the impact, but let the data talk to you. It's fun. There's a lot of stuff. I've been talking to it for 20 years. My wife thinks I'm crazy, but the data loves me. My kids think I'm crazy too, but that's okay. That's a separate conversation. So how did we start, right? The proof of concepts, like I told you, we had a lot of data. There was over 30 unique data points that we just started with, right? Because that was what we had accessible and what we were able to get our hands on. Now, those data points came in so many different formats, and we have to manage properly. Bad in will come bad out. So we wanted to make sure that the data is maintained. We wanted to make sure that things are done properly. So we went through the data, scrounged every little thing, and we did our good job. So we spent our time there. And once we finally got that all sorted out and organized, we took a very basic approach to our first proof of concept. And we applied a simple probability risk model. Now, I say simple because what we did is we did a probability risk, but we broke it down to 4 categories for us. And the reason why we took this approach is that this approach allows us to understand the different relationships between the data by itself. The univariable, for example, allows us to understand how certain data points will impact our intent and impact our intent at the solo level. What kind of direct results will it have? Now, when we started to layer in the multivariables and things like that, we started to understand the indirect results. How do things impact something else when something else is throwing a wrench in their plans, right? So that's kind of what that multivariable did, is we layered those in one by one intentionally because we didn't really know what the data was going to tell us, but we knew the intent. So we wanted to do this because it allowed us to discover and build at the same time. So 2 birds with 1 stone mentality, and it really allowed us to better find key features and feature groups that were important to us. And that's when we brought in the interaction and polynomial terms. And the math is down there, and this is not the actual math that we use, but this is the concept of it. But it allows us to see, the interaction of how the relationship between other and self. That's really what allows us to understand. Is that relationship linear, exponential, negative, positive? What does what to something else? And that's why we broke it down into these different groups. And we really went one by one with the different feature groups. And that's why we spent so much time in the beginning to break out the data points and the formats. What we wanted to do is because we categorically approached each feature group with these questions. And the reason why we did that, if my mouse would work, stalling. Yeah, there we go. It allows to kind of find key features and break down the data and kind of blend into this. So these are a couple of examples of what we wanted to look at. Okay, so soil is silt. How does the soil impact water? How does it and we looked at different types of soils and we started to see that based on different types of soils, we'll see different relationships. And that allowed us to really understand those key features. And why that was important is because we got to find the right fit for the right model, right? So I'm going to work with a little bit of analogy. Hopefully you guys will be able to understand. But when I was growing up, we had those box of toys and wooden pegs and holes, right? So when I took a square pig, yeah, I can put in a circle hole and it could work. But sometimes I might have to force it in. Sometimes I might have to shave the edges of that square, or it just didn't fit right. So if you're not careful, you're going to lose some data. Now, if you take that circle peg and you shove it into that square hole, it'll fit for sure. But you'll see some dark data. You'll see some unknowns. You'll miss out on information and knowledge that you might have not known about, right? So that's kind of how do you manage that dark data? What do you do with that kind of information? And this really allowed us to understand the things that we didn't know we wanted to know about. And that's why I wanted to kind of mention that the unbiased explanation was the biggest lesson learned for me personally, because it taught me that I'm not as smart as I thought I was. I'm always learning, I'm always constantly developing, and I'm learning with the predictive analytics. I think, as a society, we're kind of learning that with AI too. We're learning with the technology as it grows with us. So after we got into that proof of concept, being a perfectionist, we challenged ourselves. Can we do better? So the first thing what we wanted to do is we expanded our number of features and feature groups. So essentially what we did is proof of concept, and we layered on specific things like corrosion. How sensitive is the area to corrosion specifically? And we wanted to really narrow focus into that because we knew that that was a major cause of some of our major failures that we've experienced in the past. So what factors, impact corrosion is the thing that we first feature group that we developed and we worked kind of explored. The next feature group was erosion. How erosion impacts that asset, impacts that area. Is that ground more susceptible than another area? Should we go uphill, downhill? How do we have to handle the drainage? Do we need to take care of those types of things? Are we at risk? Those were the kind of things that we were trying to answer. The third category was structure, and then how likely those structural was to be impacted. Now, things like this really starts to bring in the elemental and the weather features. So one of the prominent features we saw, and we see this in California, is high wind and low dryness, right? Those are really dangerous combinations of things. So we wanted to make sure that those were there because it doesn't sound like it's structure, but those have external indirect impact on the structure. Now, for example, things start to burn and fall apart and there's high wind. Now we talk about debris. Now we talk about debris flying at high winds. Now you can see the fact that, something coming at you 30, 40 miles per hour running at you is gonna leave it pretty dense. So we wanted to kind of break those things into it and also make sure and understand, are certain structures more apt to failures of certain types? So those are the types of questions that we were trying to categorize into the structure risk model. And then the last category was foundation, because you need to have a good foundation to stand upon. So those are the last categories and that we were thinking about for foundation. It was really everything related to the ground. Is there good drainage, water pooling? May there be leaning, things like that. So as we developed the model though, what we needed to start to play around with is that this model got bigger and bigger and bigger. What took us originally, a couple of minutes to run was now taking a couple of hours just because it was looking at every combination and things like that. And running these models, comes with a cost. You've seen the high cost of data centers and you understand these GPUs to run these high machine learning and high models are not cheap. So we really wanted to balance that because we didn't want to overuse our resources. We wanted to leave not a neutral carbon footprint or a positive as best as we can. So that's what we wanted to focus on. So that was another lesson for us is that how do we balance performance and complexity? How do we balance how often are we using these data resources? Do we need to run the model every 5 minutes or is every day, every week kind of, those are the types of questions that we were really trying to look at. And then the last thing that we really was focusing on is that we learned that we're still learning. It's an ever evolving and constant learning process. Like I mentioned, I learned a lot through this process personally. The model taught me a lot. It taught me not to be so focused on thinking that I was right all the time and not trying to be perfect. Because sometimes the fun data and the interesting facts come from things that you were unexpected. Those side things that, hey, the data pops up because there's an anomaly and you look into it and you look into a new feature group and you understand, hey, look, I never thought about it from this perspective. And that's really what was the fun part about. And that's what I mean about that unbiased exploration, let the data talk to you. So after we were able to get to that models, this allowed us to really kind of be more reactive be more proactive instead of reactive. So what I wanted to walk you through is a standard screening process that we use on our model. And this is kind of how we were able to uh, talk about that prioritization and helping to be able to really identify at-risk models. So in a standard screening, you would usually associate that you would identify 50% of your issues by 50% of your screens. In our proof of concept, what we're able to do is we were able to take that and roughly identify 50% of proposed risk within 20% of it. So we really were able to prioritize and identify what was at risk first, so we can look at those and make sure that we're focusing on what's urgent and not necessarily we're trying to break down what's good to need to know and what's nice to know kind of mentality. So with the proof of concept, we were able to prove this out conceptually and through math and through our simulations. Oh, wow. And then in our model upgrade, when we actually got up there, we were actually able to expand that a little bit more. Now, we did that because the proof of concept got us really far of the way. And you're going to see these types of diminishing effects in the future. And don't worry, that's expected, that's going to happen. That's why we started to talk about balancing performance with your complexities, because some of these gains, you'll get 0.1%, 0.5%. And for some people, that percentage is important. So that's where you guys have to really think about what's important for you guys is, do I really need to fight for that improvement or not? But with our model expansion, we were pretty happy with our performance, and we were actually able to improve it slightly more. So going back to Jeremy's original problem in the beginning of 180,000 utility poles, originally, with your team, it would expect to be about 450 days to process all the data after you get the inspections and all those types of things, because you need to go through it and think about it and stuff like that. But with this methodology, what we're actively able to do is now compute all that data within 1 hour and one computer. Well, more like a GPU, but it allows us to be more flexible. It's not trying to replace anybody's mentality or anybody's job or strategy, but it's a tool. It allows us to go through the data faster now, because if it took us 30 days to process the data, 450 days to understand how your network is doing holistically, now we can process that in 1 hour, and you can look at it every hour. You can look at it every day. So you can be more proactive and less reactive. It allows you to really be able to jump at problems before they become big problems, right? So what we did is we piloted the model. So the next step was, after we were kind of done with our simulations, we worked with our engineering groups, and we were able to actually pilot this model in real world. We didn't scale it out to the entirety because we wanted to really, be intelligent, because this is very serious work. We don't want to mess it up. We wanted to take it right. We wanted to do the right thing. So we applied the model, we extrapolated it to our network, using all the data points available to us. After that, what we did is we identified the top 25 most at risk based on all the different attributes that we talked about. We went through it, we worked with the engineering group, and we were able to say, okay, look, here's our list of the top 25 things that you guys should go out, and here's our reasoning. And we actually took that to the engineering group, and they went out to the field, and they were able to confirm that all 25 did need some type of repair. Now, those repairs range from minor to major. Some of the major ones, examples are things like foundation cracks. We found some erosion issues, and we found some major bent arm issues. But some were more minor, where we just saw, like, some corrosion was a little bit higher than we would expect at this time in the asset life. But, we can live with that kind of stuff. And lastly, about that, we actually found that two of those errors or issues were actually requested, and completed while we were building the model. So to me, that was a really cool point, was that, hey, look, somebody else flagged these two because they were an issue, and our model and our predictive algorithm was able to identify those two. So that was a really cool thing that we found out. So that was our pilot, and that was our ability to really kind of understand how we did that, and that real life example. So after we expanded that a little bit more, we started to think about it a little bit differently. So that was a proof of concept, both internally and externally. So we started to kind of think about predictive analytics. Instead of just a model, it became more of an engine to us. And then from there, our model really grew, and that's that lesson learns about, you're ever growing, you're ever learning, right? The model is going to grow, and as you feed more data, find new data, collect new data, you're going to change. Your intent will stay, but your goals might change. Your hypotheses might change, right? But your intents will be there. So we started asking different questions about how can we improve stability of our network? How can we make sure our network is performing well, always at its best, always at its finest, you know? How can we prepare for the upcoming inclement weather? And how can we reduce and minimize our risk? So we started to think about that and started to really think about it as an engine, right? So that really allowed us to kind of start to think about how can we tackle problems today with asset prioritization, what if scenarios, helping with the planning of the entire system, not just our localized network, doing preventive maintenance, not just reactive maintenance, doing anomaly detection to understand when we need to be alerted, delete detection, things like that. Those are things that sometimes can slip underneath the human eye. And then lastly, proactive compliance is what we're calling it, is that compliance can get expensive. That's why we wanted to be proactive about it. Is we wanted to be in good compliance, not just from the financial impact, but also from the impact to the community, right? We want to make sure we're doing the right thing there and taking care of our people and taking care of our customers and everything. So that's what we were focusing on today. We have a couple of things that we're focusing on tomorrow, and that's where I'm going to pass it back on to Jeremy, and he'll walk you through some of our examples that we started really using predictive analytics to help really focus on some of the problems of tomorrow.
Thank you, Kenji. Yeah. So yeah, we've got the future plans, we've got what we're wanting to do, and kind of where we want to go. And as Kenji kind of talked about that pilot study, right? So diving into that was a part of our tower assessment program. It's a program we've set up with our client that really drove this, right? Wanting more, wanting to be able to help with their efficiencies and their program and their process of replacing towers. So high level, the program is 3 phases. The first is this automated or pre-screening. This wasn't quite implemented at the start of the program, but this is what we envisioned and wanted, and what drove us to build and dive into this analytical model and stuff like that. And so this is really that first phase, is where all of that happens, right? We build out that criteria, we apply it, we kind of screen the whole system, right? We've built it to scale up to our client. They have roughly 38,000 transmission towers. And so we want to be able to screen and process all of that. The second phase is really the standard assessments. And so this is where the project really started, and then we went back and built phase 1, but this is the meat of it. This is where we do the bulk of the work. We've built a prioritization scale, a rating, 1 through 6. 1 is in good condition, right? Just maintain your scheduled maintenance and repairs and all of that stuff. Verse 2, where 6 is very critical. Hey, we're catching and we're seeing stuff that needs to be fixed right away. So we dive in, we've built out a process with our client to be very much in line with what they want, how they would assess towers, right? Built off of their inspections, photos, all the stuff they're already doing, combining and building that into that assessment. And then the last phase is a detailed assessment, which we kind of turn it back over to the client. And then the client is able to kind of finalize, in a sense, okay, yeah, we agree that's a priority 3, right? We're going to do some minor repairs. We're going to start designing that, and we're going to, funnel that, or let's bump this one to a 5 because the 2 structures next to it are having issues as well, right? So this is where we are able to really define the workflow as well. So this is one of the big benefits of the model, and adding that automated pre-screening section was then we could already start sending towers down essentially two different paths. Ones and twos and threes are short, right? They're, hey, visual kind of checks, very quick, not very time intensive. We're saving time and resources there, and then resources can be spent on the 4 5s. Some of the threes as well, depending on the rating. If they're higher 3, right, maybe on that border, they go down that path as well of, hey, we're going to really dive in and look at this tower. And so now our clients have this broader visibility into their system, and then they're able to focus on more of the things that need to be focused on. So that is kind of our real world application. And within that program, that's where we piloted the model and built it all out, and really, like Kenji said, aligned it with engineering teams and all of that stuff. So as kind of an example of what that kind of looks like, per se, is, right, we have all of our assets, they're all out here. We do kind of that screening. So then we come through and it gives a rating, a pre-screening rating, something to just say, hey, we think there are some issues that might be here, might be there, all of that stuff as well. So from there, right, we do our assessments, we find out, hey, these are really there, what's needed, things like that. Start kind of defining what needs done, right? All of the processing and really being able to, in a sense, prioritize, which is the next step, right? So after that, we really dive in, prioritize, hey, we factor in, hey, this line, right, kind of over here, right, this critical structure feeds a hospital, school, police station, whatever it might be. This is where we really should be focused because of the impact that that tower has, and that there's issues there, right? So then we can say, after that, let's go up to this other area, right, where another critical structure is, and really allows you to then even refine that prioritization of your critical structures, right? We talked about like that 1%, right? Here you've identified, you've kind of found that 1%, and now you can prioritize where you need to be within that, that 1% of what needs to happen first, and stuff like that, which really is helping us keep up better, right? Be more proactive with addressing issues, things like that. So just another side note, I think we've kind of touched on it a little bit here and there, but with our clients, after reading and doing this, we really kind of found out that this is a really good start down that path of a digital twin and developing a full intelligent digital twin for our clients. So we weren't trying to build one, but as we headed down this path and built it, we just kind of realized that this is kind of that start down that path. So as Kenji also mentioned, some lessons learned, as we're kind of wrapping up this session, I really just wanted to share a few of our lessons learned from the engineering side that we have. I've kind of mentioned, right, the time savings, fast tracking those lower priorities, saving the engineers that are doing those final assessments time and resources there. They get to then focus on that critical path, right, of hey, I think these are ones issued, right? And we didn't really mention, but we there's a few different avenues of getting those, right? The life cycle structures, those equations, there's all of that based off of age, service life, right? We factor in that stuff as well too. And so but being able to factor and direct where we spend our time was huge for our clients, and that impact of time savings was greater than we thought, with being able to provide these two kind of tracks for their towers. The second one, we've mentioned it quite a few times, is that open mindset. right? Just being able to not be locked into, well, what I was calling it with Kenji, traditional engineering that I was used to, right? As I designed towers and built things, you looked at that type of stuff. And in that bigger model, it just didn't have that impact like Kenji talked about. And just being able to be flexible. And last is probably one of the more impactful lessons learned was the human element. It's not just about these machines and the machine learning and all of that stuff and the data analytics side. It's us, it's our mindset, it's having that open mind. And it's important to understand that this was just a tool to help the engineers, and it still needed that backing of the engineering and the data analytics team to mold and shape of where it needed to look and what it needed to identify and analyze. Like Kenji was saying, just chugging and looking at everything was too much, and balancing that performance really required some of that knowledge from the human element. And applying this tool, this application, in a sense, it really just, like any other great tool, right, can and will greatly increase the capacity of what teams can do and accomplish. And I think that was our biggest lessons learned and impact, and things that we saw as we implemented it with our clients and continue to improve and evolve, like Kenji said. So in summary, using predictive analytics has enabled us to keep up better, to work to be way more proactive, prioritized, improve, build a more reliable and resilient system for our clients. So with that, thank you, everyone. And what questions do you have for us? I'll kind of open it back up to Ian as well. I think he's been monitoring our questions section. So
Yep, they've been coming in. I'll first say thank you both, and let everyone know that this is, the Q&A portion. So if you do have any questions, I've put in a couple of reminders, but now is the time to put them into the Q&A box, and we'll get through, as many as we can within the next 10 minutes or so. So with that, I think we can just dive right in, and I'll just open these to either one of you, whoever wants to take any of these questions. I'll start with this first one. And they ask, at this time, are you just using this to prioritize assets for inspection, or are you also able to give the engineers info about, the type of issue to expect, so that they can take the supplies that they need for a specific type of issue?
Yeah, I can take that one. It's a little bit of both. Right now, we are focused on driving inspections, because that's what our client is focused on and what they're wanting to improve in their efficiencies within their own program. But as we're doing that, we are building, like we kind of pointed out, that, hey, this isn't a high corrosive area or a really bad erosion soil and a burn scar with atmospheric river coming, right? Identifying that for them to say, hey, after this event or this, you should go look at this tower too, and make sure that this existing condition is not as bad as we think, right? So we have kind of tilted it toward being a bit more conservative, to try and identify more things, and allowing the client then to say, hey, no, let's put it back there. So we are driving for both, but because of the client's focus, we are a bit more of just on the inspection and where to go look, finding that 1% right now. But great question, thanks.
Thank you for the answer too. We'll keep going here. This next one from Thomas asks, are there any particular tools or methods that you employed to select features within the model? And if so, what was most successful?
I'll take that one. Yeah, I think I was looking at I think it was more to your second part of the question, is that the first approach, proof of concept, was we try to layer in as many features as possible. We took everything in there, and we took a very a cutaway approach rather than an add-on approach. So we added everything in, took it away, and we did that intentionally because we wanted to explore a little bit. But there are tools out there, and we have used some other tools. We've used some tools internally that we've developed on our own, some internally out there. To me personally, I think it's just find the tool that fits for your needs. So some tools are meant for big data. Some tools are meant to compile a little bit more of the simulations of stuff. So that's, I think, really just find the tool for the need and focus on the intent is what I can recommend. But from our approach, we did a layer everything in and we'll take things off as we go, as we learn.
Okay, great. Thank you. Here's a question, and it's kind of just a general question. They ask, is there a dashboard or data portal for this tool? They're just kind of looking to get a general sense of kind of what the data looks like once you actually have collected it all and how you then use it.
A combination of both. So we do have some portals that we're using, developing internally for our stakeholders to make sure that they can transfer it, well. So we are developing some of those types of things, but we're using a little bit of some of the old school low tech stuff. We use AWS. We leverage all the high tech stuff. We're very big in AWS, so we use that to communicate well between our teams. And then we also, like I mentioned, we're doing some stuff internally to make our stuff because to be honest and sorry, there's some things that are out there that are really good and some things that just didn't fit our needs. So we're kind of compiling a Frankenstein solution of our own, if that makes sense.
Yep, absolutely.
And to add on to that a little bit is customization as well. So we have a few different stakeholders within our clients that apply. So we just did the one model tower assessment, that program, because that uses it heavily. There are others that kind of utilize that, and different stakeholders want different stuff. So at the base level, we've made it customizable, in that sense that not every data is the same, not every person wants to see the same. So we can build out and really customize what is shown. But yeah, we very narrow picked exactly what we wanted for our program, listed it all out, and built that dashboard and that tool to do the work and all of that there. So
Okay.
yeah, just a little bit there.
Maybe time for just 2 or 3 more questions here. I think when we do a lot of webinars, a lot of the challenge for attendees is getting justification to actually implement a solution in terms of like the ROI. So this is kind of part of one of the questions, and they ask, at what scale of portfolios do these predictive analytics typically deliver break-even value based on your experience?
That's an interesting question.
Yeah, so my first thought, it kind of revolves around your current process as well. If you have a lot of go back work, right? Or you went to this area this week, that area the next week, and then going back to this area, right? If you can implement some of that prioritization and bundling aspect of it, right? Saving your crews, hey, let's just do all of this work in this area, this time, this week, and then next week, right? You'll have a greater return of that investment, right? Because you're streamlining a lot of that. But if you're already kind of doing some of that, obviously that return of investment will be a little lower. But at the same time, it's still could be an interest to look at and work through and develop some of this as well. That was just kind of my first thought. It's a really good question, and time wise, I don't know if we could really dive
I'll chime in.
into
I'll chime in my analytical approach. What I would say is focus on the statistical significance of it. Now, statistical significance of analytics is going to be based on your sample size and all these types of other things. So there are situations like if you focus on the intent, for example, if you're expecting a large swing in your data, you can still be statistically significant with a small sample size because the swing is so big, right? Because the statistical significance represents mathematically the likelihood that your results will be recurring. And that's what's important, is because we want to be able to say that we can predict this type of action on a very recurring basis. We have very high confidence, right? So I think my only suggestion would be focus on the what's it called? And we can send our contact information later on so we can discuss this because this is a very interesting conversation. So I would love to continue it with whoever it may be, but yeah, I would say focus on the statistical significance and the intent, because then you can kind of find the solution that fits because the scalability is really to your problem. It's you can have a low tech, high tech solution. It really depends on the intent of what you're trying to do. Right? Because you don't have to pay, Meta, Facebook value kind of machine, Microsoft, ChatGPT prices when you can try to do some of this stuff locally. You can train models locally and stuff like that too. So
Right.
yeah.
Yeah, absolutely. I think we are out of time here. I know there's
I
some
would,
questions remaining, and I will say that Jeremy and Kenji's information is up on the screen, and I will be sending out the slide deck as well, so you all have that. If anyone does want to, follow up and continue the conversation, I'm sure we could go for another hour pretty easily here. But with that, before I do wrap it up, I'd like to give you both the opportunity if you have, any concluding remarks, anything you want to leave everyone with, and Jeremy, maybe we can start off with you.
no, just really a big thank you for listening to us today, participating in this. Hopefully, you did learn, hopefully a little something. And yeah, this was extremely fun. I loved it. We're still developing and working with it. It is super interesting and being able to do that. So really, just yeah, again, a big thank you to everyone.
Yeah. I wanted to thank you guys really because being in analytics and in engineering world, sometimes I feel like I'm an island on my own. But all those thumbs up and you guys, I really felt like you guys are my peers. So I wanted to say thanks for like listening to me really. It felt like it was like ranting to my peers. So it was fun, it was great. And I hope to talk to you guys some other time.